solving a system of equations using the elimination method. If you want to follow along, I took these from starting on page 36 in the Math 20 Pure textbook. Okay, so the first thing you want to look for when you're solving something using elimination is check and see if any of your variables have the same number for the coefficient in front of it. So here our x's, we have a 3 and a 5, they don't match. The y's both have a 2. So that's the first step is identifying that. So we're going to eliminate the y's here because it will be easiest. Second thing you look for is whether or not the signs are the same. So if they're both positive, both negative, or whether they're different, if one is positive and one is negative. If they're the same, we subtract. If they're different, we add to cancel them out. So in this case, we want to eliminate the y's, so we're going to add these to cancel them. So you add every single term, all the like terms as well. So 3x plus 5x gives us 8x. 2y plus negative 2y gives us 0, so that just cancels out. And 19 plus 5 gives us 24. Now we have to divide both sides by 8, and we'll solve to get x is equal to 3. So now we've got one of our variables. All you have to do is look at one of your original equations, sub that in for your x, and you can solve for the corresponding y. So we've got, I'll pick the second one, 5 times 3 minus 2y equals 5. So here we get 15 minus 2y equals 5. Move the 15 over to cancel, and we get 2y is equal to negative 10. And divide by negative 2 to get y equals 5. Here's another example where we look for a common number as a coefficient, and our x's in this case both have a 4. Now we look, okay, are the signs the same or different? In this case, they're the same. They're both positive. So we're going to subtract. 4x minus 4x cancels. 3y minus a negative 7y minus a negative is like addition. And then 5 minus 15 gives us negative 10, divide by 10, and we get y equals negative 1. Take that number, sub it back in, so 4x plus 3 times negative 1 equals 5. 4x minus 3 equals 5. Add 3 to both sides. And 4x equals 8. Divide by 4. And we get x equals 2. Lastly, if we're come across a problem like this where we look for, remember, first step is check and see if any of the coefficients are the same, our x's are different, and our y's are different. So now we have to use a little bit of multiplication to solve this one here. So we can either choose to eliminate the x's or choose to eliminate the y's. You always want to pick the ones that'll have the lowest common denominator. It just makes it a little bit easier because you're working with smaller numbers. In this case, I would eliminate the y's. So we've got a 2y and a 5y. Lowest common denominator is 10. So you have to ask yourself, what do I have to multiply these equations by in order to get both of these coefficients of y to be equal to 10? So in this case, I need to multiply it by 5 to get this to be 10y. So the whole equation gets multiplied by 5. And again, this whole equation will be multiplied by 2 in order to make this a 10y. So we'll rewrite our equations below after you've multiplied. So we end up with 15x plus 10y is equal to 10. And we end up with 8x plus 10y is equal to 24. So now the question is, we have the coefficients to be both positive 10. Look at the signs. Are they the same or are they different? In this case, both of our 10s are positive, so we're going to be subtracting. So 15 minus 8x gives us 7x, 10 minus 10y gives us 0, and 10 minus 24 gives us negative 14. Divide by 7, divide by 7, and we get x equal to negative 2. Sub it back into your original equation. I would sub it back into one of these originals. I wouldn't use this one because your numbers are a little bit bigger here. So go back to your original equation, and we've got 3 times negative 2 plus 2y equals 2. Divide both sides by 2, and we get y equals 4.